Hello and welcome to another video. In this video, we're going to be working on minimum number of operations to make array empty. And in the problem, you're given a zero-indexed array nums consisting of positive integers. There's two types of operations you can apply. You can take two elements with equal values and delete them, or three elements with equal values and delete them. Return the minimum number of operations required to make the array empty, or -1 if it's not possible. So in this first example, we have 4 2s, so that would take 2 operations to get rid of. Then we have 3 3s, so that would take another one, and then 2 4s, so it would be 4 total operations. And then in this one you can't, because you can't get rid of this 1 because we only have 1, so we can't get rid of 2 or 3. So there's kind of two ways to do this problem. It's kind of obvious what you want to be doing, right? So if you have a bunch of numbers, let's just say you have some numbers, you want to figure out a way to know how many of each of them you have, right? Like let's just say I have like, and I'll write them sorted. So let's say we have something like this. We want to know how many of every number we have, right? Let's say we have some 3s here or something. So one thing you could do is you could sort the numbers and then just like go and count up how many you have in a row. And then once you know how many you have in a row, deal with that chunk, then get the next chunk and the next chunk and the next chunk. And that's one way to do it. The other way is you can just make a hash map of all the values. So instead of sorting the array, you can say like 1 will have a count of 5, 2 will have a count of 3, and 3 will have a count of 2, and then use those values to do stuff. And you don't really care about what number, you only care about the count of the values, right? So let's say we have something like this, and let's actually use some bigger numbers just so we can show this. So let's say we have 51s, we have 32s, and we have like 25 like how do we go from this to a result? Well, ideally, if we choose to get rid of 2 or 3, we just want to always get rid of 3 if we can, right? But how do we actually know how to do that? Because for example, what if our number is 10? Well, we could get rid of 3 times, but then we'll have 1 left over, and then we can't get rid of this. So you can't just like get rid of 3 as much as you can and then get rid of the rest. But there are a few situations that your number will fall into, and it's reasonably easy to figure this out once you just like try this on a few numbers, right? So let's do that. So situation number 1. So first situation is like the one that you can't do anything. So if it's 1, can't do anything, right? Like we can't get rid of 2, we can't get rid of 3, so this would just be return, -1 because it's not possible. Situation number 2. Number mod 3 equals 0. Like if we had a number like 51, let's say, well, we can just like delete 3 elements that number of times, right? So if this is 51 mod 3 is 0, 51, we can just take 51 divided by 3, which would be 17. And then we know we can just perform the delete 3 operation 17 times, right? So here we can just add number over 3 operations. Now there's 2 more, and this is going to be repeating, so that's why it's going to be nice. So number mod 3 equals 1, right? Like for example, so in this case, let's say we had 52. Well, we can delete 3 17 times, or we can even use a smaller number to show this. Let's say our number instead of 52 or whatever is like 16. Well, we can just delete 3 5 times and we'll be left with 1, but that doesn't work. But instead what we could do, and you could try this for all kinds of numbers and this will always work. So instead of deleting 3 5 times, right, instead of deleting as much as you can, we can just delete n-1 times, right? So instead of deleting 5 times, we can delete it 4 times. And if we delete it 4 times, then we'll have 4 left over, and this will always be the case as long as your number is big enough. So we basically just take number floor divided by 3 minus 1, and that's how many times we want to actually perform the -3 operation, right? So in this case, it would be 4 times. If we do it 4 times, we will subtract 12. We will have 4 left. And then you will always have an even number, right? Because you'll always have 3 plus 1 left because this is 1. So instead of having a 1 left over, you'll have a 4 left over. And then when you have 4 left over, you just do the delete by 2 twice, right? So 4, you can just do delete by 2 or divide by 2, right? So you can go 4 to 2 and then to 0. And that would take 2 operations. So essentially your total number of operations is number 4 divided by 3 minus 1 plus 2 more because you'll always have a 4 left over essentially. And so that simplifies to this, right? So if you have number, number mod 3 is 1, then your total number of operations is going to be add number floor divided by 3 plus 1 operations. And then finally we have, let's see, I guess we have 2 more cases, right? So what about this one? So number mod 3. Actually, no, I think we have, no, we only have 1 more case, right? We have this one. Yeah. Number mod 3 equals 2, and that'll be like this 50. So what do we do here? And everything else is repeating, right? Because let's say we have a number like 48. That will be this case. Then 49 will be this case. Then 50 will be this case. Then 51 will be this case, and it'll be repeating all over and over and over. So this will always be true. Okay, so let's look at this case. So if we have a number like 50, or we can use a smaller number once again, let's use a number like 11. So we have 11. What can we do here? Well, this one's going to be easier. We can just divide, we can just get rid of 3 as much as we can, right? So we can just floor divide by 3, do that as much as we can, get a remainder. So if we floor divide by 3, we can do this 3 times. Then we'll have a remainder of 2, and then we can use that divided by 2 operation. And we can do that for every number. Same thing with 50. So 50, we can keep removing 3. How many times can we remove 3? That's going to be 50 floor divided by 3, which is 18 times. Then we'll have 2 left over, the remainder, and then this is 1 more operation. So this is the same kind of thing. So this is add number mod 3, and then 1 more operation as well. So this and this is going to be the same number of operations, because for 3, you will basically do the 3 operation and this many times minus 1, and then you'll do the 2 twice. And for this one, you will do the get rid of 3 this many times, and then you'll only do the 2 once. But the number of total operations is the same. You'll just have 1 less get rid of 3 operation in this case. Well, actually, sorry, in this case, right? Yeah. But the total number, that's all we care about. The total number is going to be exactly the same. So 3 and 4 basically have the same thing, so we can make it smaller. So basically our cases are number equals 1, return -1, number mod 3 equals 0, add number floor divided by 3, and the rest add number floor divided by 3 plus 1. And that's pretty much it. So we can do these in constant time. We just get a count, and then we go through all of these counts. So we don't really care even like what numbers we're getting rid of. All we need to know what the count, all we need to know is the counts. So we will go for like the 50. Which case is that going to be? That's going to be this case. So this is going to be 19, right? Because it's going to be 48. Actually, I don't think it's the math. 48 over 3, it's going to be 16 plus 1, so 17 here. And that makes sense because we will basically get rid of 3 16 times, have 2 left, and then get rid of 2. Then this 30 is going to be in this case, so that's just 10. Then 25 is going to be in this case. So in this case, this is going to be 8 plus 1, so 9. And that makes sense because what we would want to do here is we wouldn't want to get rid of 3 8 times, because if we get rid of 3 8 times, we'll have 1 left over. We'd want to get rid of 3 7 times, then we would have 4 left over, and then we'd want to get rid of 2 twice, which would give us 9 as well. So we just add all these up, and we will get 36. So that's kind of how you do it. Just get a counter for all your variables and do these cases. Kind of intuitive to figure out because they basically cycle, right? Your numbers first, mod 3 is going to be 0, then mod 1, then mod 2, and then it's going to loop back, right? As you keep adding 1 to the number, it will basically cycle through all of these. And yeah, we just have to check in the beginning. And this also works for 2. So let's say our number is 2, which that will be this case here, which will work as well, right? So number mod 3 is 0 plus 1 will be 1, which is correct because we would want to just do the 2 operation 1 time. So it does work for 2, works for 3, works for anything other than, like I said, for 1, you can just manually check, is my number 1? I can't do it then, but any other number can be made using 2s and 3s. So let's code it up. So basically, we can just have a result variable, and we can loop through all our numbers. Actually, before we loop through all our numbers, we want to get the counts of all our numbers. So we can say counts equals counter in Python like this. This will basically give you a dictionary of every single number and its count. And then we just want to go through the count, so we don't really care about the numbers, right? So we can say like for count in counts values, right? We want to just go through the values of the dictionary. Now this is where we want to actually do our stuff. So if count equals 1, that means there's no solution, so just return -1. If count mod 3 equals 0, we want to add count floor divided by 3. Otherwise, the other two cases are going to be the same thing. So it's just count floor divided by 3 plus 1. And now we can return result. And we can even combine this into one thing. So we can just say like result plus equals count floor divided by 3 plus. So you can actually put this in an if statement. So you can say basically what we want to do is check if it has a mod, right? So if it has a mod, you want to add 1. So the way to do that is you can just say like a bunch of different ways, but you could say like 1 if count mod 3 else 0. This works. So basically, if there is a mod, add a 1. If not, leave it like this. Okay. And there we go. So pretty good. And yeah, the other way to do this, like I said, this is kind of the same as doing like a 2-sum. So the other strategy is sort the numbers, and that way, if your numbers are sorted, you can just go through them and get the count as you go instead of having a dictionary. So you would have like, let's say something like this. You would just like keep going while the number is the same, maintain a count as you go, and then once you get a new number, you do this logic on whatever count you had. So that would also work with sorting. So up to you, both of those would work. So this one is going to be O of n time and O of n space. I think it's reasonably intuitive. This will also pass if you weren't able to figure out this like mod stuff that it kind of cycles. If you actually make a function that figures out how many 1s and how many 2s and 3s are in some number, you can have a recursive function that does that as well, right? You can basically just do like a DP function that'll take some number, and then you like try to subtract 2, try to subtract 3, whatever one gives you the most, you keep recursing. Whatever one gives you the most, you just return that. And then anytime you get like a negative answer, you just return like infinity or something. So if you weren't able to do that, so that would also pass, because that would be like an n log n solution or something. Because essentially when you have a count, anytime you try to subtract 2, actually, I don't think that would be an n log n solution. I think it would be a little bit slower. Maybe like, yeah, I think it would be a little, actually I'm not sure if it would pass, to be honest. Because, no, I think it would pass because all your counts add up to n. So you basically have some kind of like 2n solution or something. Like, I think it'd be fine. It would still pass, I think. But this is a little bit more kind of like neat, I guess. So yeah, that's gonna be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. Hopefully my mic is good now. I don't have as much background noise, so let me know if there's still issues. And thanks for watching.